Hello and welcome to DeveloPerSpective. Today we'll speak about a hot topic. The topic of what is better. Is GraphQL better or is RESTful API better? Why should I use GraphQL and why should I use RESTful API? What is the similarity between a GraphQL and a RESTful API? And the most important topic, what is the difference between a GraphQL and a RESTful API? What are the new features which are available in GraphQL and what are the features that GraphQL doesn't have as compared to the RESTful API? If you are new to GraphQL, don't worry. We have a brief discussion on what is GraphQL and how the GraphQL works. So in this video, you will get answers to all these questions. And we'll have a practical implementation of both GraphQL as well as RESTful API. So do watch this video till the end to exactly know what technology you should use for each of your applications. So first, let's start with what is RESTful API and what is GraphQL APIs. So RESTful API is an architectural concept for network-based software, whereas GraphQL on the other hand is a query language, a specification and a set of tools that operate over a single endpoint using HTTP. So RESTful APIs are basically used in all the new APIs built on top of HTTP, which holds the transition state of each APIs, and hence helping the standardization of API structure. Like, you know that GET is used for retrieving the data, POST is used for creating new data, PUT is used for updating a data, and the same way delete is used for deleting a specific set of data. So this all standardization has been brought in by the use of RESTful API. Whereas GraphQL is a query language, which actually is used to improve performance and to improve the flexibility of the interaction which you do with the underlying data source. So let's put things into perspective. You would have heard a lot about RESTful API. Almost all the application developers has always come across or at least heard about RESTful API. It is one of the most commonly used API architectures at current times, and it works amazingly well with all the application architectures around application development. Because of the loose coupling features, standardization of the interface, and even having been vastly adopted by new budding fields like OEM, that stands to Original Equipment Manufacturing. But let's speak about the practical implementation of a RESTful API. Imagine if you are creating a web application that integrates a RESTful API to your frontend, and while working, you found out that you are missing a field in the response of that endpoint. So in such a case, let's see the normal practice we follow. So we now have to go and add a new field to the database. Update the backend RESTful API to be able to take that input. Update the GET API to allow getting that field in the response, along with some operations which has to be done on top of it. You need to then deploy your application to the server. And now you can go ahead and update your front-end code to do these changes. And if you are just a front-end developer, then you may have to wait for the back-end developer to get these changes done and deployed. But wait, what we wanted was just to add a new field to the existing system, isn't it? So if you go for GraphQL, the process you need to follow to make these changes is, first, you need to go ahead and update the schema of the database by adding the new field. Now, go and update your front-end code to do the changes. Yep, that's it. These are the only steps you need to do to accommodate these changes. And the same goes for most of the operation we do with all the RESTful API. If you need to add more filter to your application, no need to update the backend. Just update the query you pass to the GraphQL, that's it. If you plan to create new join to merge two tables together and get a response, you don't have to do any update in the backend code. You just have to structure your query accordingly and make a GraphQL query. That's it. Theoretically speaking, GraphQL has no backend to it. It just has a single HTTP endpoint on which you can do all the operation you want to do with the data source. Unlike RESTful API, which requires you to have a different endpoint coded in the backend to help you with all the desired responses and all the desired endpoints and operations you want to do. So most of the time, RESTful API is either overfetching or is underfetching. So basically, GraphQL is a DSL based querying language that eliminates the need to have a middleware application to interact with your data source. And it provides tools and APIs to ease your access with the data source in question. There is more to the story. What better to describe a story with comparison and then the differences. So let's now compare RESTful API with GraphQL and then we'll go for the differences. In RESTful API, we have a method like GET to retrieve data with or without a filter. In GraphQL, we have a query to do that. In RESTful API, we have methods like put, post, delete for updating the data. In GraphQL, we have mutations to handle these updates. Both the RESTful API and the GraphQL work on top of HTTP protocol, but still GraphQL has many protocol supports under its hood. Different data sources are allowed on both of the REST and the GraphQL APIs. You can have multiple different type of data sources like database. You can have types like APIs on top of APIs as a data source in RESTful API as well as in GraphQL. So this is kind of the comparison between the RESTful API and the GraphQL. Now let's speak about the hot topic, the topic of the differences between RESTful API versus GraphQL. So the first one is RESTful API will have different endpoints for each functionality, whereas GraphQL has a single endpoint, and on top of it we have different functions like queries and mutations to create different functionality out of it. In RESTful API, we need to hardcode the functionality at the server end, and each changes in the query has to be done on the server side. Whereas in GraphQL, we don't have to have a lot of changes done. We just need to create functions, and within that the queries we can still modify. And this is done on the front end side. On the same line, RESTful API has full control of the logic of the functionality on the backend side. Okay, so you have the entire logic written at the backend. Whereas in GraphQL, there is a little control, or mostly everything is exposed on the front end. So all the querying, all the filtering is normally done on front end, and that is how it has to be, because GraphQL is for performance improvement and for easy query. Querying in RESTful APIs are limited to the structure of the API. So you have a defined structure of an API which allows you to query some part of the data structure, and adding new queries has to be done on the backend side, and then a front end integration has to be done on it. Whereas in GraphQL, queries can be created on the client side itself. You can create a join, you can create filters on the front end side, and just go ahead and put in the query and you will get the appropriate filters done, and the projections of the data can be retrieved from the GraphQL. When we speak about caching, there is no direct support to GraphQL when it comes to caching. Whereas RESTful API can leverage the HTTP caching on browsers. So if you have seen on browsers, most of the APIs or most of the endpoints of RESTful APIs are cached on the browser. Okay, but that cannot be done on GraphQL because we don't have different endpoints to each of the different functionality which we want, right? So there is a single HTTP endpoint, and your browser cannot cache a single endpoint because that endpoint has a lot of different functionality it adheres to. Okay, so caching is not possible on a single API on which your GraphQL is working on, whereas in a RESTful API you have different endpoints to each of your queries, or different endpoints to each of your requests, and we can leverage the technology of HTTP caching to enable caching features on RESTful APIs. And last but not the least, one of the most fascinating difference I find in GraphQL over RESTful API is the ability to notify changes. Yeah, the ability to notify changes. What I mean is the application has a notification mechanism inbuilt. So whenever there is a change in the database, or whenever there is a change in the mutation or the query, you can add a new subscription on top of it. So what will happen is any other application which wants to get updated when there is some activity on the mutation of a data set happening, then you can subscribe to that mutation, and whenever there is a mutation triggered, you will get a notification. Okay, so the service or a different application can get notification on any activity which is done on a dataset by using a subscription on the specific mutation. So this feature helps a lot with a lot of functionality which you need in your application, like you can having a logging mechanism on top of it, you can have broadcasting of changes, and even notifications in your app. Okay, so all these features you can have it there. Even it can support the MQTT type of thing where you want to get subscribed to a specific topic, or in this case it's a mutation, and you will get notified whenever there is some changes happening to the system. So this is one of the most fascinating thing I found about GraphQL. Okay, so now we understand what is GraphQL and what is RESTful API, but still there is a huge misunderstanding between the GraphQL and the RESTful API's usage. So normally people believe that GraphQL being a querying language, or GraphQL being a query oriented technology, it can be used under a RESTful API. So you can have a RESTful API endpoint, and behind that you will have a GraphQL querying, just like you have an ORM like Hibernate which does the querying stuff of the database. But that's not true. GraphQL and RESTful APIs are completely different. Those are basically a replacement of each other. You can either use RESTful API or you can use GraphQL because of the differences in its architecture. The way the GraphQL works and the way the RESTful API works are completely different. So now we'll understand what is the architecture which GraphQL follows and what is the architecture which the RESTful API follows. And this will surely clear out all your doubts related to GraphQL and RESTful API for sure. So now let's see the architecture of RESTful API. So RESTful APIs, as I said earlier, is all about endpoints. So each endpoint has its own functionality. So to call a RESTful API, we need to call the endpoint. So we'll just request that endpoint with some parameters. So then your application is listening to all these endpoints and it exactly knows which function to be called when this endpoint is being triggered. Now the request is received by a specific function which is mapped to that endpoint, and it does the processing on the server side. This processing can be done on multiple data set. It can be done on whatever logic that has been put into that function. And these functions are very stringent because that functions are hard-coded. In the sense, the logic is all hard-coded. We cannot change any response or the request type during that processing. When the processing has been completed, the processed data is sent as a response to the client. This is all about how a RESTful API works. So in this case, the request and response is always static. In the sense, the data may change, but the structure almost stays the same. You can try to put multiple if-else conditions to have different responses, but still the APIs would be limited. So you cannot change the API the way the API behaves from the front end. So if you want a new data which has to come from a response, that cannot be done from a front end dynamically. Now let's see how the GraphQL works. So in GraphQL, as we spoke earlier, it is all a single endpoint. So there is no multiple endpoints, there is only a single endpoint through which you can interact with GraphQL. So the client sends a request to a single endpoint, which is actually the entry point of your application on GraphQL. Along with the request, we also send the queries, which has the projection as well as the filtration if you require. So you can have different set of filters and different querying and the data set which you want out of it. So if you want like 3 fields and you want it to be queried on the specific field of your choice, then you can do it right away at the request itself. You do not have to do that on the backend. Now the GraphQL on the server side has a query parser. So what it does is it understands the query and it translates it into something that is understood by the GraphQL. Each query will specify a schema associated to it. So each query has a schema to it that makes GraphQL understand which is the schema it is referring to. And each schema will be binded to a resolver. So resolver is nothing but a function that helps the schema understand the data source. So as we know, GraphQL has support to multiple data sources. The same way as REST has support to multiple data sources, the GraphQL also has support to multiple data sources. So to resolve which schema belongs to which data source, we have to have a resolver function. So this is just to resolve the schema associated to the data source. And once the schema understands the resolver, it has to point to the processing of the query takes place and the response is sent out to the request. So this response is delivered on the basis of the query which was generated by the requester and not by any logic that has been put it on the resolver or on the GraphQL side. Okay. So all the logical thing and the querying and the projection has to be sent from the client, then from the backend. So this is the vast difference between what is RESTful API and what is a GraphQL, because in RESTful API the processing of data happens on the server side, whereas the GraphQL, the instruction of what has to be queried and what should be processed is done from the client instead of that being done on the server side. So I'm using AWS AppSync. Using AWS AppSync, I'll be able to use GraphQL to its full potential. So to do that, I have already logged into my AWS console. And here you can search for AWS AppSync. I can create a project of AWS AppSync and this is called as AWS AppSync APIs. So to create an AWS AppSync API, just click on this create API. So here we can have direct integration with Amazon DynamoDB. So that is what we'll be using instead of creating any other application. You can have many different type of data sources, but for this demo I'll be using the Amazon DynamoDB. So I don't have an DynamoDB with me currently. So what I'll do is I'll create a DynamoDB from scratch with this wizard. So I'll just click on this create with wizard. So to start with, we need to first create a model. So that is the table which I want to create, and this will act as a schema as well, a model schema for the GraphQL. So book would be a model which I'll create, and the book will have an ID, a title, and an author. Okay, so these are the different fields I'll be using for this model named as book, and you can have some additional table name and stuff which I'll just keep for now as book table, and the primary key will be ID. So this will automatically create a DynamoDB for me. I will name this API as book API. So this would be a very simple application which handles creation of book and display of book details. So just click on create. So now this is creating the DynamoDB table. So once this is completed, you will be having this different type of queries. Okay, so this is an API authenticated GraphQL. So this will have an API key. So now if you see, so this has automatically created some mutations and queries. So if you see, there is this create book, delete book, and the update book mutations. And these are some of the queries like get book and list book. Okay, so these are some of the basic mutation which comes by default when you create a GraphQL using AWS AppSync. So first of all, let's see the schema of this API. So when you go here, you will find this define the schema, and here you will find edit schema. So if you see, this is the schema which has been created for me. So this has the book as the type, and it has ID, title, and author. It has some connections as well. Okay. So the most important thing is the mutation. So if you see, there are this mutation which is present. So this is create book mutation, update book mutation, and delete book mutation. In the same way, we have some queries, that is get book by ID and list book, and it takes in filter, limit, and next token. Okay, so this is the most important aspect of queries, where you can have custom filters and limits and things like that. And we will also see the projection, how we can handle projections on top of these queries. And if you see, this is the subscription which will be triggered whenever a mutation is triggered, like the create book mutation, update book mutation, or the delete book mutation. So these are different subscriptions which you can subscribe to and get notified whenever there is any of this mutation getting executed. Now the other aspect to this is the resolver. If you see at the right, we have resolver. So here if you see, each of this mutation is resolved by a specific resolver. Okay, so each of this mutation and the query has some resolver attached to it. Okay, so let's go ahead and see what are the different resolver here. So when you click on this book table resolver, it will redirect you to a resolver. Okay, so this is what a resolver looks like. Okay, so this is something that translates your graph query into a format that the data source understands. Okay, so your data source is DynamoDB as such for this application. So this resolver is responsible to convert your GraphQL query into a format that is understood by DynamoDB. So if you see, this is a put item request. So DynamoDB has many different type of operations, out of which put item is one of the operation, where it takes a dynamically generated ID. So ID will have a dynamically generated ID to attach to it. So that is done by using this auto ID, and each of the input. So CTX ARG input is nothing but the JSON which we will send as a body here. Okay, we will also map how things go. So input is actually the key on which we will pass the entire body. Okay, so we'll map all those things when we try to execute a new query. So before that, let's see if the DynamoDB table has been created, which is our data source. So we have this table created, that's the book table. So what we will do now is let's go ahead and create some entries, and I'll explain you how this operation happens. So we'll just try to create one entry into the book table using the GraphQL. So in this page we have something called as run a query. So just click on run a query and this will open up a page where you can go ahead and execute any of your queries. So here I will find for the mutation and put it out here, and here I will try to execute this create mutation query. So how do you do that is by putting some details here. So for example, I will just put author as Mike. I don't know who is that, but I'll still put in Mike. And the title can be like My Life. Okay, so this is the title of the book and the author is Mike. So here the projection would be author, ID and title. Okay, so this is what a query would look like. So my query of mutation is with the name of my mutation, and the mutation I am calling is a create book mutation which takes in input. Okay, so you need to keep in mind that input is a key and the value associated to it is a JSON which has author and title as a key and which has appropriate values to it. Okay, and the projection I want to do is author, ID and title. Okay, so let me execute and let's see what happens. Okay, so to execute just click on here. Okay, so this got executed and I got the response as create book which has author, ID and title, and if you see the ID is auto generated. Okay, so how did this happen? That we'll check when we go back to the resolver, and by that time let's see if the database has some entry created here. So just refresh this page and if you see, yes, we have this data created which has an author and title. If I go back to the resolver, you can see that it's a put item. That's an operation to create entries to DynamoDB. And if you see, the ID is an auto generated ID. Okay, so that's a util.dynamodb.toDynamoDB JSON which takes in util auto ID. Okay, so this will automatically generate a unique ID for you. Okay, and if you see the attribute values would be getting from a JSON map, and that map would be taken from the context and the argument. This is a function and these are the different arguments given to that function. Okay, so each function will have an argument and the first argument which you see is an input. So that's the reason I am using dot input. So that's the reason I am getting this entire argument set. Okay, so this is nothing but a JSON key value pair. Okay, so if you see, this is a map so the JSON map is converted and it is passed as an attribute value. So this is how the resolver works. It actually translates your JSON query into a format that a data source understands, and this query is nothing but the query which is understood by your data source, which is DynamoDB. Okay, so DynamoDB understands what is this put item. Okay, and it translates it into the operation which the DynamoDB understands. Okay, so this is something that comes from GraphQL, and this is something that the DynamoDB understands. So in the same way the response works. So this is the request. So whenever the request comes, this is how it is converted and it is sent to the DynamoDB. And once you get a response from DynamoDB, this is how you convert that response into something that GraphQL understands. Okay, so this is how things happen here. Okay, so that is how your ID gets created and your data is inserted into database and you get a response which is understood by GraphQL. That's how you get a response, something like this. So in the same way we have queries as well. Okay, if you see queries, you will have a list query, and if I want to execute list query, I can have filters associated to it. For example, if I want author who is equal to something, so whose name is equal to Mike, and the projections I want is author, ID and name. Okay, if I just want the title of the book, I can just say this. I don't want the other two items, and I can just do a my query, and I'll get the title of the book where the author is equal to Mike. Okay, and this is an entire thing which I can customize. I can have multiple different filters and projections, and this will go that way. So it will project according to what I requested for. Let's quickly see the resolver for list book as well. So for that, I need to go to the schema. Here I will find this list book, and there is a resolver attached to it. Just click on the resolver, and this is the resolver, how it looks like. So you will have a filter. This JSON is understood by, again, DynamoDB, and the operation is a scan. And here you can have like filters, and then you can have custom code as well here. So whatever the data source you have, you can just convert your request into something that is understood by your data source. So you have different limits here, next titles and all those things. You can customize your data source, and on the basis of that you can customize your entire GraphQL. So if you see, the query works excellently well here. So this is a query builder, or this is a query resolver type of thing where I can build queries and I can execute and check it right away here. But this is not something very convenient when you integrate your application with your front end or something like that. For that, you have a lot of tools which you can implement, a lot of CLI based tools, a lot of API based packages which you can implement in your front end application and get this executed. But for this demo, we will try executing these same queries on Postman. So Postman is a tool which helps you execute HTTP based APIs. Okay, so I can just use Postman to execute this. So for that, first of all, we would require a URL, and as we already know that GraphQL has a single endpoint or a single URL on which each of these operations can happen. Okay, so there is no different URL or endpoint for each of the operation. There would be only single URL for the operations. Okay, so that URL I can get from here. So I'll just go to the setting, and if you see, this is the URL I have. Okay, so let's jump into the Postman, and then we'll try this out. So once we go to the Postman, let's create a new request, and this would be a type of post request, and I need the URL or the endpoint of the GraphQL. So for that, let's go to the browser. Here I'll copy the URL, the API URL, paste it here. Then, as is an API based authentication, so I'll be using API key here. So for this, I'll have a header with a key as XAPI key, and the value would be a value which I get from here. Okay, I'll just copy this and paste it here. So now let's go to the body. As this is a post call, so we'll have to have some body associated to it. So I'll keep it as raw body, and here I'll choose a JSON, and I'll create a JSON which will have keys like query followed by variable if you want, or else you can keep it as null, and you will have something called as operation name. So this is the name of the operation which I'll execute with this query. So this will take in the query, this will take the variables if any, and this would be the operation name. Okay, so let's go for a simple operation, and then we'll go for a complex one. So simple operations like list, that will give you all the details like this. Okay, so this would be my query. Okay, so what I'll do is I'll just copy this, paste this here. Okay, so I would have to format this to make it as a string. So for that, so programmatically you can use any of the JSON libraries which will convert this entire JSON into a string format. So I'll do this manually for now. So we have the query with us and the operation name. So we'll also have to send the name of the operation which we want to execute. So the operation name would be my query. So the operation name would be my query. So now let's go ahead and send this request. and if you see, we have the response. So let's try to add some more complexities here. So with this, I also need a filter as well. Okay, so here let's try to add some filters. So I'll say anything, I say author with the name is equal to Mike. So this would be my query. So if I execute this, so I'll get everything that matches to Mike. So I still have one entry only, but you need to believe that it is querying on the basis of the filter. So I have this extra query param which is passed to that function. So I'll just copy this, and if I go and paste it here, so I'll have the filter with this function. So I'll just have to convert this into something which makes it a string, and now if I query, I will get the same data. Okay, if I just change Mike to something else, then there is no data here. Okay, so this is how you can modify the queries. But as I told you, I am not using a different URL for this API call. I can do the same for mutation. I can do for all different type of queries. And also if you see, I just have to change the request body, and on the basis of that, the responses changes. Okay, so if I put in something else, so here we did not have the filter earlier. I added this just now, and this works without any problem. So if I don't want this filter, I can remove this. Also the projections. For example, if I don't want the title to be coming with this API, so I'll just remove this projection, and if I send it now, I will get all the details, but only the author and the ID. I will not get the title because I just removed that from the projection. Okay, so that's how the things work in GraphQL, where you do not have to have different API endpoints for all the operations. Instead, you have a single endpoint and you have a bunch of queries which you can execute, and these queries can be customized as per your need. So this is how the GraphQL works. The second part would be, we'll try to have a RESTful API with the same features and the data source, and let's see how optimized it is, or let's see how better is the performance and how flexible it is to accommodate changes to your request. So for the sample RESTful API, we'll be using the same DynamoDB table, that is the book table. So we'll be using this table as a data source for a RESTful API. So to create a RESTful API, I'm using SpringBoot as a RESTful API application development framework, and I have created this controller. So this has two endpoints. So in RESTful API, we need to create endpoints to each of the functions or the functionality which we want to create. So for that, I have two different functions. One is the list book and the other is the create book. Okay. So list book is responsible to list all the books in the DynamoDB database table. So the create book is to create items in the book table of the DynamoDB. And to test the functionality of dynamic projections and to check the functionality of dynamic queries, for now we'll just have two attributes to this table. So we'll be using just two attributes in our code, which is an ID and the title. Okay, so we also had one more attribute which you can see here, and that had the author as well. So here we haven't specified the author, we just specify the title and ID. Okay. So just to compare how GraphQL and RESTful API works when you do not specify the projection or when you do not have the proper mapping done in your code. So I'll just run this code here. Okay, so it's already running. This application is hosted on localhost 8080. So I'll just go ahead and try to create an entry in book table. So I'll continue using Postman to query all the APIs. So I'll create one more Postman request. So this request would be a type of post request because I'm creating an entry here, and the URL would be http:/localhost8080/createbook. So if you see, we have the API as createbook, and that's the type of post request. So I'll be using this, and the body it takes is the book model, which is nothing but this, which has item and title to it. So we'll try item, title and author as well because we have that in the database, and see how it works. So create book API, the body will be a JSON body. So we'll just pass title as my second book, and I'll also put the author and see what happens. So it would be James. So let me try to hit this API and see what happens. Yeah, and if you see, we have the ID created, but the thing is only the title was considered and the author was not considered. Okay, so let's see in the database if it is saving anything there. So here if I refresh, you will see I just have the title, I don't have the author. Okay, the reason being the model does not have a capability to handle author. Okay, so there is no way I can dynamically add any new field to the database until unless I don't have a mechanism explicitly written to handle this type of scenario where there is no key and value. So that's a very tedious work to be done, and you can have different technologies on top of RESTful API which will be able to do that. But ideally this is how it will be, so you'll have to have some mapping there as well. So let's try the other API, the list of book API. So I'll create one more entry here. So I'll create one more request here, and that request should be list books. Let me hit it now. Yeah, and if you see, I just have the ID and title, but here in the database I have the author as well for at least the first entry. Okay, but I do not see that because that's not present in the RESTful structure itself. So for RESTful structure, you always have to define the models on which you want to work on, and the definition has to be very stringent. Okay, and one more thing to note is that for each small change I have to do an explicit coding in the backend to be able to accommodate those changes. So first of all, if I want to add a new field here so that I get that field, I have to first of all define that field here. So we have the field as author, right? So we'll have to define that field here and then again restart the service. Okay, the reason being this refresh has to be done, and if it's hosted somewhere, then we'll have to deploy the changes as well so that the application have the corresponding changes. And now if the service is up and if I try to hit this API, I should get the author as well. Okay, so for each small change, I have to make a small change in the backend. So there is no way I can just change something here and it will automatically work. Whereas in this API, the GraphQL API, if I wanted to add author, that would be very straightforward by just using the projection here. So I have this. Okay, so author is already there. I will just add title here. So if you see, this will not have a title. So if you see, when you hit the send now for GraphQL, you will just have ID and author. So if I want a new field added here, I can just go ahead and say like I want a title as well here, and just go ahead and hit the send. Yeah, so we have the title as well, right? So that's the difference. That's the major difference which a GraphQL and a RESTful API has. So if I want filters, I can have like filters here and I can make it dynamic and all those things, and that's not a very hard thing to do for me using GraphQL. Whereas if I want to do the same thing in RESTful API, I'd have to do all that configuration and the logic at the backend. So I don't have some filters in the list as such now. So to handle that, I would have to again add some changes in the controller to be able to handle the filters and to be able to handle different type of APIs, right? So each of those will have to be created. Okay, and the dynamic things cannot be handled here. I have to do it all from the backend. I cannot do it on the Postman itself. I cannot go and add a filter. I cannot define the projection. So if you see the list book as well, in the backend I had to add specifically that I want author, and only then I was able to extract the author details. But if one fine day, if I want to just have the IDs and do not have title and author, I cannot do it using this API. So either I have to update the backend to accommodate those changes, or I would have to have a different functionality on top of this which allows to have that type of filters when you respond to this API. Okay. Whereas this type of operations are very easy and much more efficient in GraphQL, which you can see in this demo. So this is all about how practically GraphQL differs from RESTful API. And also GraphQL has an ability of subscription, which you can see here. So if you see, there is this different type of GraphQL subscriptions. So this, when you subscribe to a specific GraphQL subscriptions like on create book, if a new entry is made to the book database, automatically this function is triggered, and any application which subscribes to this subscription will get notified with all these different details of your choice. So you can have projections like if you just want author, if you just want title, whenever you do the operation, you can do it right away using these subscriptions. So that is one more additional features which GraphQL gives on top of RESTful APIs. So this is all about the GraphQL and RESTful API. If you have any question related to GraphQL or RESTful API, do put in a comment on this video. I'll be happy to help you out. Also, if you found this video useful, go hit the like button. And if you are new to this channel, don't forget to subscribe. So thank you for watching.